Okay guys, let's take a look at today's lesson. Today's lesson is on the difference quotient and the average rate of change. This is really an all calculus day. These are all calculus concepts. In fact, a lot of the things that we do here in Precal Tag are related to calculus, which makes your choice whether you choose AB or BC calculus. It makes it, it'll be good for you because you've already done a lot of calculus in pre-calculus. It should be an easy transition no matter which way you decide to go. So let's talk about the difference quotient. Here's the difference quotient right here, this little formula. And this is used in calculus to define the derivative. Actually, in calculus, we would take the limit of the difference quotient. We would do the limit. We're not going to do limits today. We're just going to find difference quotients today. But our goal in finding the difference quotient is we use this formula, and then our goal is to get rid of this h in the denominator. That's our goal, algebraically. So we're going to work through that and see how that plays out. So in calculus, the limit as h goes to 0 would be in front of this, and so hopefully you can see the reason why we would want this h to be gone. Right, because if our limit is headed to 0 and this was a 0, we know that would be bad. Right, so our goal algebraically is to get rid of this one single h on the bottom. You can have h's on the top, it's fine. You can have other h's and combination of things on the bottom, but this single one has to go. Okay, so that's our goal algebraically. And this is a picture of what this is talking about. So if this is our original point, x1, y1, if I have some number h, some kind of change in x, so this would be, in this particular diagram, this is h, this distance right here. It looks like a little bit more than 3. And so this is our h, so x plus hy. So what we're doing is we're creating this quotient with this x plus h minus f of x over h. So that's what we're doing. And in calculus, we're going to add this extra piece on. We're going to do the limit as h goes to 0. And that's going to find us the derivative. That's what that is. It's called the definition of the derivative when the limit is attached. Okay, so we're just working on difference quotient today. The other calculus topic that we're going to be looking at is average rate of change. It's a formula, f of b minus f of a over b minus a. And so what is it? What is average rate of change? Well, average rate of change is the slope of the secant line. Now, we may not have talked about secant lines since geometry. A secant line, in fact, this portion right here, that's a secant line. It connects, it's like a chord, if you will, from geometry. It's a chord that we have points that connect, that chord to the curve. Here, this dotted line right here, that's the secant line. This dotted line. Here's our little formula. And what we're doing here, b is the x value that's farthest right, and a is the x value that's farthest left. That's important to keep in mind. And then f of b minus f of a. So my y value at b minus my y value at a. And so that calculates the slope of the secant line. Really, this is just a slope formula, change in y over change in x. Okay. Then increasing, decreasing, this is a review for us. We have already talked about increasing and decreasing functions. As you are reading like a book from left to right, we read the graph, and if the graph is rising, as we're reading this way, if it's rising, that would be considered increasing. If it's falling, that's decreasing. And so those different sections are, depending on what's happening, increasing or decreasing. And yes, there is a big fight. I may have talked about this before. Mathematicians actually have an argument. Can you believe that? I mean, they seem so nice, right? Yes, they argue about whether we should include the, this top right here, whether we should include that point or not include that point. So some mathematicians believe that we should include it, therefore the brackets. Some mathematicians believe that we should not include it, so parentheses. And each side has its own set of theorems to prove their point. So on the AP test, you can do either. For me, you can do either. I kind of tend towards the parenthesis route, but you can do brackets if you want to. And that is the increasing and decreasing. So those are the topics that we're going to be looking at today. Are there any questions so far? Okay, we just have a few examples on the next slide to work through. So let's go over there. So the first one is to find the difference quotient. You know, like I explained before, I'm just doing one example. You're going to have a lot of different kinds. This is a radical. You know, you'll be doing difference quotients for fractions and for polynomials, all kinds of different functions. I'm just doing one, the one with the radical. So we would need to know what the formula is. At this point, I'm not going to ask you to memorize it. No matter which calculus you choose, that's going to be emblazoned in your memory next year. So it's not, you know, but I will write it down on a quiz or a test for you to use. So there's our formula. That's our difference quotient. So let's talk about function notation. We've been dealing with function notation for years, and some students are still confused about it. So this is telling me to take the function f, and everywhere there's an x, I'm supposed to insert an x plus h in its place. That's what this says to do. Take the function f, insert x plus h where the x is. Then I'm supposed to subtract the function. So you see how the function appears twice in my formula? Once with an x plus h in it and once with just the regular x in it. And then that's over h. Okay, so let's do that. So here in this particular function, there's just one x. It's right here. So I'm going to open that spot up and I'm going to insert an x plus h in that spot. So that right there is my first step. That's given me the f of x plus h. Minus. Okay. The second spot is just the function, just f of x. So f of x is just the square root of x. And that's all over h. All I have done so far is just substitute into the formula. Okay, there's a little bit of a confusion on that earlier today about substituting into the formula. We really need to, and it was this piece that was confusing students, really need to understand what that is saying. No matter how many x's you have in your formula, you're going to open up that location and put an x plus h inside of it. Okay, are we okay with that function notation? It doesn't matter how many x's. If you have 5 x's, you're going to do it 5 times. However many x's, you're just going to put this in place of x, the x plus h. Then you're going to subtract the regular function. Okay? So as I was explaining, our goal is to get rid of this single h here on the bottom. That's our goal. And so with radicals, the technique that we use is multiplying by the conjugate. We're only allowed to multiply by the number 1. That's all we're allowed to multiply by. So I need to multiply by that conjugate, which would be the square root of x plus h plus the square root of x over the square root of x plus h plus the square root of x. Okay, so recall the conjugate is where we change the middle sign. All right. So now let's multiply. We know the first times the first. You know, those are identical radicals, so it's going to be x plus h. We know outside, inside. The beauty of the conjugate is the outside and inside multiplications go away, right? They net out. So this times, you know, this outside, and then add the inside, that's 0. So I don't need to do that. So then it's just last and last. So negative root x times the root x is a negative x all over h times the square root of x plus h plus the square root of x. Okay, so that's my first round with the conjugate. I just multiply all that out and that's what I get. So now my job is to simplify that. See, we have the x minus x. See how those x's are going to go away? I'm going to be left with h over h times the square root of x plus h plus root x. Okay, you see what we can do now? We can cancel those h's out. All right, those h's are going to go away right here. I'm going to be left with 1 over the square root of x plus h plus the square root of x. That is my difference quotient. Now, if we were in calculus and we wanted to find the derivative, we would go one more step. And I'm just going to show, we're not going to do that in this, but I want to show you where you're going next year. So we would do the limit as h goes to 0 of the difference quotient. Do you see what would happen if we substitute a 0 in for h? See what we get? We would get 1 over root x plus root x, right? And that's just 1 over 2 root x. This is the derivative of that. That's what we would have found. We would have found the derivative. Okay, now we're not going to go this far. I just wanted to show you how it finishes out so you really understand why we have to get rid of this h in the denominator. Okay, that's why it has to go, is because it would cause this to be undefined or indeterminate form, depending on what we were doing. Okay, so this would be the derivative. This is where we're stopping, though, today. This is where we're stopping. We're just going to find the difference quotient, simplify it as much as we can, and then stop. Okay? So there's our answer. On the second one, we're looking at average rate of change. We're going to find average rate of change, so we need to use that formula, which is f of b minus f of a over b minus a. Okay, that's the slope of the secant. So what some students like to do is they like to write out what a and b is, and they like to write out what f of a and f of b is. They like to write all that out. Some students just want to plug right into the formula. You can do whichever one you want, but you do need to use the formula. Okay, whichever one. I'm going to go ahead and write them out because I know some students like to do that. So a, if we go over here, a is going to be the points farthest left. So our a value, the x, is a -1, and b would be 1, 2, 3, 4, 5. B would be 5. Okay, that's a and that's b. Okay, so f of a, that is the y value at a. The y value at a is 0, and the y value at b, let's see, 1, 2, 3, 4, is 4. Okay, so that's writing all of that out. Again, that's just a step that some students like to show. You don't have to if you don't want to. So now we're going to take these numbers and we're going to put them inside of our formula. And so f of b is 4 minus f of a is 0 over b is 5 minus a is a -1. Okay, so this is the step that I need to see. I need you substituting into the formula. And then you can just give me the answer. Okay, so formula, then answer if you want. Or you can do other steps. It's up to you. But bare minimum, I need formula and then answer. So the formula, so 4 minus 0 is 4. 5 minus a -1 would be 6. So that would be 2/3. Okay, that's my average rate of change. We okay on that? Okay, let's go to one a little bit more difficult. All right, so here we're wanting average rate of change between the given values of the variable. So x is 1 and x is 1 plus h. So we need to determine which is smaller, and I'm going with h as positive because we just can't do everything right. We can't think of it as positive or negative. So I'm going with h as positive, which would make this one smaller. So that is my a, and that is my b. Okay, so 1 is my a, and 1 plus h is my b. So I do need to find f of a and f of b, so let's go through that. This is going to take a little bit of work, so we'll write it out like I did over here. Just kind of work it out. So f of 1, that's my a, is 1, would be 4 minus 1 squared, or 3. Okay, so that's my f of 1. Now f of 1 plus h is going to be 4 minus 1 plus h squared. Okay, we okay with that so far? I'm just using the formula. Now I got some algebra to do, right? I need to FOIL and do some stuff like that. So let's do that. So f of 1 plus h is 4 minus, and some of us can FOIL in our head, which is perfectly fine, or if you need to expand it, that's fine too. So that's going to give us what? 1 plus 2h plus h squared. So let's clean this up a bit. So let's see, 4 minus 1, that gives me a 3. And then I distribute the negative to the other parts of this, and I get negative 2h minus h squared. Okay, so I have my a and b. So I have my a and I have my b. and I have my f of A and my f of B. I have those are my 4 pieces that I need to plug into my formula. Right? So f of B first. So we do 3 minus 2h minus h squared. F of B minus f of A. F of A is 3. All over B minus A, which will be 1 plus h minus 1. Okay, I'm going to pause here for a second. Are we doing okay? Am I going too fast? No? Okay, so this is what I'm left with. Now I need to clean that up. We need to clean it up so we can see that 3 minus 3 is gone. Right, so in the numerator I have negative 2h minus h squared. In the denominator we see that the 1 minus 1 is gone. I'm left with an h. Do we all see what we can do now? Right, can we factor out an h? So factor out an h. I'm left with negative 2 minus h over h. That cancels. And my average rate of change is negative 2 minus h. Okay, is that okay? All right, so that is a total calculus lesson. That's pretty fun, right? Right? Calculus is so much fun.